Now, just like with an arithmetic sequence, how you can change it to a series by adding the terms together, you can do the same with a geometric series. Now, geometric series are a little bit different, however, because you can add a finite number of terms or an infinite number of terms. We're going to start with adding a finite number of terms, okay? So this would be a geometric series that only has a certain number of terms that we're adding together. The formula for a geometric series is the following. Sn, which is the series, is equal to the first term times 1 minus r to the n, and that's in the numerator, and then divided by 1 minus r. Okay, so a little bit challenging of a formula. But to use this formula, we need three things. We need the first term, we need the ratio, and we need the number of terms. Okay, once we have those things, we just need to put them into the formula. Okay, so number 3, we have all of those things. We have the first term, which is 256. We have the ratio, which is 1/2, and we have the number of terms, which is 9. So let's do our sum. So the series is equal to the first term, 256, times 1 minus r, 1/2, but that r is raised to the n power, so raised to the 9th power, divided by 1 minus 1/2. Okay, so the challenging part of this is simplifying this, all right, because this is a complicated fraction here. We need to simplify it. So we'll start by simplifying this and this. Okay, these two can be done essentially at the same time. So what we get is 256, 1 minus, so 1 to the 9th is 1, 2 to the 9th is 256, or 512, I mean. So this is 512. And this is over 1 minus 1/2, which is 1/2. Okay, next we can do this. That gives us 256 times 1 minus 5 over 12. Now you want to keep this as a fraction, so the best way to do that is to change 1 over to 512 over 512. So this is 512 over 512 minus 1 over 512. Okay, that's the best way to look at this because 1 can be expressed as 512 over 512. So that's 511 over 512. And then that's over 1/2. Okay, so this is essentially 256 over 1 times 511 over 512. We can multiply those two together right now. That will give me 256 times 511 over 512. Now the reason I would write it this way is because 512, and we're still over 1/2. We still have this over 1/2. The reason I would write this fraction this way, and let me just rewrite it actually like this. So we'll rewrite it as divided by 1/2. Now the reason I would write it this way is because 512 can also has a factor of 256. It's 256 times 2, which means that these 256's can cancel. Okay, so what we're left with is 511 over 2 divided by 1/2. Okay, well that's the same thing as 511 over 2 times 2 over 1. Okay, but then you have these 2's, they cancel. So what are you left with? You're just left with 511. So our series is equal to 511. You add all those terms together and you get 511. Okay, so it really comes down to just, can you simplify these problems? Can you simplify these fractions? Now you may also see the problem in this type of notation. Remember, you can very quickly change a sequence to a series just by using the formula. Okay? You put a E in front of the formula, and that will give you a series. The bottom number tells you what term to start at, and the top number tells you what term to end at. Okay, so remember, well, here, so what we need for the formula, we need three things. We need A1, we need the ratio, and we need the number of terms. Number of terms is the easiest one because it's just the top number minus the bottom number plus 1. 7 minus 1 plus 1, okay, which is 7. So there's 7 terms here. The next easiest one is the ratio. The ratio is always going to be in the same place because remember, the formula for a geometric series or sequence is an equals a1 times r to the n minus 1. R is always the number in the parentheses with the n minus 1 as the exponent. So R would be the number in parentheses that has the exponent. So it'd be -3. So R is -3. Now to find the first term, which is the last thing we need for the formula, we just need to plug this in to this. Okay, so if we plug that in, we get 4 times -3 to the 1 minus 1. So 4 times -3 to the 0, okay, that's just 1, so it's 4. So the first term is 4. So now I have everything I need to use the formula. Okay, I need all three of these to use the formula, and now I have them. Okay, so the formula is Sn equals A1 times 1 minus r to the n over 1 minus r. I just need to replace everything. So Sn equals 4 times 1 minus r, -3, to the 7 over 1 minus -3. So remember, you can do this one and this one to start with. So that's 4 times 1 minus, so -3 to the 7th, which is -2187 over 1 minus -3, which is 4. Oh, okay. So let's keep going. So we have 4 times 1 minus 2187, which is 2188. Now you'll notice I have factors of 4 in common here, so I can just cancel those. So all I'm left with is 2188. So the sum of my series here is 2188. All right, not bad, 2188. So all right, and then our last example here, you rescued the king's daughter, he's offering you a reward. First option is $1 million all at once. The second option is getting the reward over 30 days, starting with 1 penny the first day, 2 cents the next day, 4 cents the third day, and so on, receiving twice as much each day. How much is the second option worth after 30 days? Okay, so that's a summation because we're adding all the days together, so that's a series. So the three things we need for the series are the first term, which starting with a penny. We need the common ratio, which is telling us how much is multiplying by each day. Well, it says twice as much each day, so it's multiplying by 2. And we also need the number of terms, which in this case is the number of days, which is 30. So we have everything we need to do this equation, or to do this formula. So we're just going to plug it into the formula, 1 minus r to the n over 1 minus r. So you got 0.01 times 1 minus 2 to the 30th over 1 minus 2. So remember, we can do this one and this one to start with. 0.01 times 1 minus 2 to the 30th is probably pretty big. Yeah, it's very big. I'm not going to have room for it here, so let me move this. 0.01 times 1 minus 1073741824 over 1 minus 2, which is negative 1. Okay, next I can do this. Okay, so I got 0.01 times 1 minus 1073741824, which is negative 1073741,823, and that's over negative 1. Unfortunate. Of course, my thing would crash right there. Let me pick up where I left off, so I don't have to start over. Okay, so where I left off was I had the sum 0.01 times negative 1073741823, and that was over negative 1. Okay, so multiplying this by, so I can do this next. So that would be negative 10737418.23 over negative 1, and that just turns it positive. So 1073741823.23. So this is actually $10 million. Okay, so this is way better than the $1 million that he offered us up front. Okay, it would be actually much better to just take the double reward where it starts at a penny and doubles each day for 30 days. Okay, because then we end up with over $10 million, which is much better. All right, here are the problems for this one.